Good afternoon, everyone, or good morning, or greetings. Hope you're having a great day. We are on our last lesson for chapter 6. And so oftentimes when we learn things in math, we learn all of the skills, and then that very last section in the unit is word problem day. And so today is word problem day, where we are going to look at some applications. I did include, I think, I included a PDF or a Word document that has those that you can print out or have reference to. I always like to do this, and I'm trying to kind of mimic an in-person setting, even remotely. So if we were meeting in person, I would make copies of this and hand this to you so that we don't have to spend our time writing out the questions. So I would encourage you to have that maybe open on a different window, or hopefully you can print that and then you can write right there in the notes and circle the things that are important as we go through these word problems. We are not going to do every single word problem that you see in this section. I kind of just touched on the most important ones to me. And I took out some ones that just are those types of questions that you see in a math class and then would never see again in real life. Like if you look at the electronic version of the book, you will see problems known as boat in the river questions, and whether or not you're in a boat going upstream and downstream and how fast the river is flowing. And I'm thinking to myself, we live in the desert, so like no one, like this isn't necessarily applicable, and we can explore application problems without doing every single type of problem. So as you can hear in the background, I start talking and my dog starts barking, so hopefully that's not bothering you too terribly much. Our first example says Sally can fill a certain order in 5 hours. Brittany needs 9 hours. Working together, how long will it take them to fill the order? And so these are called work problems. And in general, your strategy is this, and this is not like something you're going to see in the book. This is kind of my little shortcut here. So 1 over the first person, we have to create some type of fraction for it to be in this chapter, and then 1 over the second person working alone equals 1 over together. So that is the basic strategy of how we're going to solve for x. So let's read it again. Sally can fill a certain order in 5 hours. So here's Sally. Brittany needs 9 hours to complete the job. The number on top in the numerator is always a 1. How long would it take them to do it together? This is the unknown. This is what the question is asking, is how long would it take them working together? And so that's where the x goes. Once we have the equation written down, it is the exact same lesson that you just did in 6.6. It is how to solve for x when x is in the denominator of a rational equation. So if you recall from that lesson, we are going to figure out what our common denominator is, and we're going to multiply everybody through. So we need a 5, a 9, and an x. So our LCM, aka our common denominator, is 45x. And remember that I tend to write this, some students choose not to. I tend to write it next to each little fraction, because now I can cross out each piece. 5 goes into 45 9 times. So I have 9 times x, everything's multiplied, times 1, 9x. 9 goes into 45 5 times. I have 5 times x times 1 plus 5x. And here, my x's cross out, and I have 45. So after I write it down and do one step of clearing that fraction, I have an equation that no longer has a fraction in it. You're going to get weird answers here, and it is okay. And so x would be, 14 is going to go into 45 about 3 times. And I did not grab a calculator in advance, so here you are watching me having to do this on video without a calculator. So this is 42, so I have 3. So that's about 3.2 hours. Since these were hours, your answer is in hours. All right. I do one, you do one. So if we were in an in-person setting, I would show you one, I would give you one to do. The try is right there on the worksheet. Maybe I won't erase all of this. So try the try, and then let's go through it. So pause here, and welcome back. And it says a tank can be filled in 18 hours by pipe A alone, and in 22 hours with pipe B alone. How long would it take them to work together? This one is a little bit more complicated due to the fact that finding that common denominator might take a little bit more work. So I am pulling out my phone calculator here in case I need it. 18 is 2 times 9, which is 3 and 3. 22 is 2 times 11. So when I'm thinking about my common denominator, or LCM, I need a 2, I need 2 3s, and I need an 11 and an x. So 2 times 3 is 6, 6 times 3 is 18, 18 times 11, I am not sure I can do spontaneously off the top of my head, 198x. So we are going to write down 198x right here. We are going to write down 198x right here, and 198x right here. 18 goes into 198 11 times. 22 goes into 198 9 times. And here the x's cancel. So once you identify that LCM and multiply through, cross out your common factors, we're at this stage right here. Add those two together. Divide by 20. Divide by 20. This really is almost at 10. It's going to be about 9.9, I'm guessing. It would really round practically up to 10. And so there's your final answer. The little squiggles is an approximate because it's not quite equal. All right. If you need a little bit more practice, perhaps, the ones on the back of this page are on page 2. Similar, not exact, but a lot of the strategies are the same. So with the work problem, we still have this 1 over the first plus 1 over the second is 1 over together. So looking at example 2, and I'm going to read the problem that talks about Bob can paint the house. So, example 2, Bob is painting his house in 9 hours more time than it takes Sarah. So in this problem we have Bob and we have Sarah. And I need you to ask yourself, who is faster? Read through the question and think about who is faster. Bob can paint his house in 9 hours more. So Sarah's faster. Bob, it takes him 9 additional hours. And so those are the two expressions we're going to write to satisfy how much time it takes each of them to paint. Then, for this problem, it says together. So this problem gives us this answer. Together they can paint the house in 20. How long would it take each of them working alone to paint the house? So we're going to solve for x. We're going to use this same strategy. We know this is going to be x, this is going to be x plus 9, and we know together it's going to take them 20. And once we solve for Sarah's time, we can easily substitute back in to find Bob's. So 1 over, 1 over, 1 over. The strategy is the same. Multiply through by that common denominator. So we need a 20, an x, and an x plus 9. We need a 20, an x, and an x plus 9. A 20, an x, and an x plus 9. We need a 20, an x, and an x plus 9. It does take a little bit longer to write that out. I just think it's well worth it to keep your work organized. I would throw this in parentheses. And let's cross out those factors. This x cancels with that x. So we have 20 parentheses x plus 9. This cancels with this, so plus 20x. And here the 20s cancel. So we end up with an equation that looks a little bit more complicated than what we were getting on the first page. But we can handle this. All right, we're going to distribute. We're going to gather like terms. You can see right here we're going to end up with an x squared. So we should anticipate having to factor. Here we go. So 20x multiply through plus 180 plus 20x equals x squared plus 9x. Just distributing here and distributing there. I'm going to bring it up to this side. I don't know how low my camera is going. And that glare. 20x plus 20x is 40x plus 180 is equal to x squared plus 9x. I want to keep that x squared positive. So even though it's on the right and it's going to feel like it's a little bit backwards, I want to make sure I factor with that x squared being positive. So I am going to move this 40x to the right. And those are going to be like terms. I'm going to move that 180 over. Remember just the general rule, if you're positive on one side, you're going to be negative on the other. And so all of this is gone. So I'm left with x squared minus, I have a positive 9 and a negative 40. So minus 31x minus 180. And now I'm going to need to factor. So I need two numbers that multiply to 180 that create 31. And since this is a negative 180, one of my factors is going to be plus, one of them is going to be minus. I'm sure 4 goes into 180, 45. 5 goes into 180, 30. There it is. Okay, so you just kind of have to keep going through thinking of things that go into 180 until you find the right combination. So we have a negative 36 and a positive 5. So when I set each factor equal to 0, this goes back to that chapter 5 lesson, and add 36. You can see this will give us a positive answer. If I subtract 5 here, 5 there, this has to be thrown out because time can't be negative.